Hey everybody, my name is Mr. Balistreri or Mr. B, and this video is a video you need to watch if you want to do some of the experiments that I am going to have posted here on YouTube. This one is some background information that you need about experiments. So it's not going to be too long. So once this video is watched, I will post um, the next one, and that one will contain all the information needed to set up and run the experiment. But this one is some background information. It goes over some of the things we covered in class that you might not remember or you need a refresher on. Got my friend Jeff here helping me out. He's going to keep an eye on you, so please pay attention, just like you do in school. And the first thing is that think about what an experiment is, right? An experiment is run to answer a question, right? It solves a problem, it figures something out. And within every experiment, there are variables, okay? Variables are things that change. Sometimes they have to do with time or height or weight or any number of things, temperature, pressure. Variables can come in all sorts of ways. So what I'm going to do to help clarify these concepts for you is think about that experiment we did the very first week of school this year, right? I held up two objects. Um, one was much heavier than the other. They were about the same size. Like one was one of those little squishy toys that you squeeze when you're under stress, right? I could really use one of those right now. And one was a rock that was about the same size and shape, and I held them at the same level and I dropped them at the same time. And we wanted to figure out which would hit the ground first, right? That was the problem or the question we were trying to solve in that experiment. So let's look at the variables. I want you to have this clear idea of what variables are in an experiment. So um, one of the variables we had to control, right? We need to make sure this is something that did not change from trial to trial, um, was the height that we drop the objects from, right? So think about it. Would it make much sense to drop one of the objects from this height and one from this height, right? No, that wouldn't make any sense. Obviously, the one that's closer to the ground is probably going to hit the ground first, right? So the variable of height at which we dropped the objects from, we had to make sure they were the same height. Another variable that we needed to control in that experiment, a variable we needed to really make sure was accurate and correct, was when we dropped those objects. Because again, it wouldn't have made much sense to drop one object and then 2 seconds later drop the other, right? We had to make sure we let go of them at the exact same time. So that was another variable we had to control. Wind resistance was a variable we talked about, right? Because if you were dropping these objects from like the top of the school building and it was going to drop a long distance, maybe that wind resistance would really slow down the lighter object, right? Um, so to help mitigate or make up for that difference, right, to make sure that wasn't a big issue, we didn't drop it from very high off the ground, right? We didn't give wind resistance or air resistance much of a chance to affect this experiment. So I only dropped it from a couple of feet off the ground, and that seemed to make sense to me. So um, the one variable we wanted to be different, right? Now think, can you remember what that variable was? I already mentioned it once or twice. Jeff? No, Jeff doesn't know. I don't think he was in class that day. Probably overslept. Um, the variable we did want to be different was the weight of the objects, right? That was the thing we wanted to be different from one another, the weight of the two objects. Now, we ran that experiment 3 times. Now, we're going to do that when we do any experiment. We're going to run multiple trials. That way, in case we do make a mistake in one, maybe we don't make that mistake in the other. And we want to make sure we be as careful as we can in all 3 or 4 or as many trials as we do, right? And we got to keep those variables consistent again. So you wouldn't, for example, you wouldn't change the weight of the objects from trial to trial. We drop the same objects from the same height at the same time in all three trials. I'm not going to, I don't think I mentioned the results of that experiment yet. I hope not. And I won't in case you want to run that little experiment yourself, because maybe you weren't in my class. Maybe you're just checking out videos on YouTube and you came across this one, which is great. All right. The other thing we need to talk about, it's very important. It's called the scientific method. The scientific method is an agreed upon set of steps that scientists follow when running an experiment, right? Um, the reason we follow these same steps, no matter where we are, no matter who we are, no matter what experiment we're doing, is in case another scientist wants to check our results. If they follow the same steps, then the results can be compared accurately, right? So now I realize my steps in my scientific method in my class aren't going to be the same as some other teacher across the country, but they're going to be close, right? They're going to include mostly the same thing. Um, some of them have to be in a particular order, right? So let's get into that. Steps one, two, and three, there's seven, but the first three steps of the scientific method have to be done before the experiment. Step one is the question, right? It's the thing we're trying to figure out. It's the problem we're trying to solve. Going back to our little example of dropping the two objects, for that one, the question was probably something like this. Which object, one that is heavy or one that is light, will hit the ground first when dropped from the same height at the same time? Right? You could reword that. It could be worded a little bit differently, but the idea is to ask which one will hit the ground first. It sets up the rest of the experiment, right? That's the question. That's the thing we're trying to figure out. Step two out of steps, the seven steps, is background information. Background information is what you already know about this topic, right? It might come from research. Maybe you read a book. Maybe your teacher talked about it. Maybe your parents did something with it. Maybe you looked it up on the internet. Maybe you saw a video about it. Maybe you experienced it in real life. Maybe you were throwing stuff up in the air one day and you saw how fast they fall compared to one another. Any experience you have that could help you figure out the answer to that question we asked in number one is your background information. It's really important stuff because you're going to use that background information to answer that question in step three. Step three is the hypothesis, right? It's your educated guess at the answer to the question. So steps one, two, and three, you have to do before the experiment. It wouldn't make any sense at all to answer the question, I'm sorry, to think of an answer to the question after you ran the experiment. Because once you run the experiment, you're going to know the answer to your question, right? That's what the experiment is for. It's to prove or disprove what you think is going to happen. So whenever you're doing an experiment, make sure you get your question, you think about your background information, and you write down your hypothesis. Once those three things are done, then you do the experiment. Now, there's still some steps left, right? We're not done. Step four is simply a list of the materials you're going to need to do the experiment. Going back to our example, we didn't need much, did we? All we needed was two objects that were about the same size, right? That was another variable we wanted to control. We didn't want one being really big and flat and then having trouble with that huge thing and something tiny and small. We wanted them about the same size so they would act the same way as they fell through the air. That was another thing to mitigate that wind resistance problem we could have had. Um, so yeah, all we really needed were two objects about the same size, and one was heavier than the other. And when you're writing your step five, which is coming up, is the procedure, you could give a little bit more detail about that. But all we really needed for materials was two objects in that experiment. And as I just mentioned, step five is the procedure. This is step-by-step directions on how to run the experiment, right? So when you're writing your procedure, you're writing sentences, you're writing maybe paragraph form or just listing it in bullet points. but it's important that you get clear steps that anyone could read and follow who wants to do this experiment. You don't want to give too much detail, right? You don't want to say in our little experiment, you don't want to say move your left hand and pick up the heavy object. Move your right hand and pick up the light object. That's too much detail, right? You don't need to say that. But you want to make sure you mention hold them at the same height, release them at the same time. So it's kind of tricky because you don't want too much information, but you need enough information so they can run it accurately. So I always try to tell the kids when we're in school, when you're writing your procedure, ask a lot of questions. Get help from somebody. Make sure it makes sense. Make sure it doesn't sound silly because you're putting in too many tiny little details, right? All right. Step 6 is data collection. Every experiment has data. This is the information you're collecting while the experiment is going on. And it's different and it comes in different forms, right? And you show it in different ways. It all depends on the experiment. Going back to our example, the data was actually watching which one hit the ground first, okay? And seeing that and writing down somewhere, either in a sentence or in a little chart you could draw, saying the different trials, trial 1, trial 2, trial 3, recording that information is step 6, data collection. I just mentioned trial 1, trial 2, and trial 3. I want to make sure I get that in here. You always want to run the experiment more than one time. And you can set that up right in the experiment. Like the one we're going to do um, first, there's trial 1, trial 2, and trial 3 built right into the experiment. And I'll explain that when we get there. But for this one, I just made sure I held them up and dropped them 3 different times. And I recorded the information each time. And if I was careful to control my variables, I should get the same results every time. That's what you're looking for in an experiment. Control your variables, and no matter how many times you run it, you should get the same results. And then you know your outcome is correct. All right, that was step 6, data. Finally, step 7, conclusion, right? Now, this can be done any number of ways. Here's how I would write a conclusion for experiments that we're going to be doing. Part 1, I restate my hypothesis. Part 2, I say what really happened, okay? And part 3, I tell whether I was incorrect or correct and say if I learned something, right? So again, restate your hypothesis, tell if you were right or wrong, and make sure you give a little bit of a statement saying if you learned something from the experiment. That's what I require for a conclusion. So I'm just going to give a random example. I'm not going to say how this example or this particular experiment turned out in case you want to run it yourself, but it might sound like this. Again, I'm not giving away anything here. In my hypotheses, I guessed the heavy object would hit the ground first. As you can see by my data, I was incorrect. The light object hit the ground first. I learned that lighter objects hit the ground before heavy objects. So that's an example of what a conclusion might sound like. I want to say again, that is not how it turned out. You want to find out how it turned out, run the experiment if you weren't in class with me that day. All right, so we're almost done here, guys. This is kind of a long one, I know, and I hope you've stuck through it the whole way. I mean, come on, if Jeff could make it. Um, so let's just review real quick. An experiment is run to answer a question, to figure something out. Every experiment has variables, right? Some of them you must control. You must make sure they're the same every time you run the experiment. And there's usually at least one where the variable needs to be different, right? There's a different situation, and that's what you're testing. The example we use, we dropped two objects, one heavy and one light. The variables we controlled, height of the objects to be dropped, weight of the objects to be dropped, or that was the one that was different, right? We wanted it to have different weights, but we had to drop them at the same time. And then we talked about the scientific method. Question, number one. Background, number two. Hypothesis, number three. Those three must be done before the experiment. Step four is a simple list of the materials. Step five is the procedure. Step six is data collection, and that data could come in many forms. Could be in a sentence, could be a picture, could be a measurement of temperature or weight or speed or distance. It all depends. And step seven, of course, is the conclusion. And those are really important. Restate your hypothesis, tell if you were right or wrong, and what did you learn? All right, I think that's about it for this video. The only thing I want to tell you, if you're going to want to do the experiment that we're going to set up, the next video, it's going to be about the growth of mold on bread. So what you're going to need is probably two pieces of bread, right? Two whole pieces of bread that you cut into 4 slices. Now, each of those slices is going to go into a different environment: wet, dry, light, dark. So if you have 2 pieces of bread, you'll be able to have 2 of those little squares in each environment. That's the minimum, right? So you need at least 2 pieces of bread cut into 4 little squares, okay? If you want to run more trials, you'll need more bread, right? One trial is 1 piece of bread cut into 4 pieces. What I'm going to do, I'm going to use 3 or 4 pieces of bread, and I'll have 3 or 4 trials just to make sure. So you can just do 2, you can do 3, but cut them into 4 little slices, all right? And you're going to need a Ziploc bag for each little square of bread, right? So if you use 2 whole pieces of bread cut into 4 pieces, you will need 8 Ziploc bags. You'll probably want a Sharpie marker to label the bag too, all right? So again, if you want to run this experiment, try to get these. And again, when I put that video up, it's going to be up there forever. So you don't have to run the experiment the day you watch the video. You can watch the video, go get your materials, come back and watch it again, right? Good. So again, though, just one last reminder. You'll need at least 2 pieces of bread, at least 8 Ziploc bags, a marker. Oh, and you'll need a little bit of water. What I'm going to recommend when you set up the experiment, unless you have a spray bottle that has nothing else in it, you can't use a spray bottle that has some kind of soap or disinfectant or something in there, right? If you're going to use a spray bottle for this water we're going to need, it needs to be a clean spray bottle, all right? Otherwise, all you need is a little bowl with water in it, okay? Just a little bowl of water that you can dip your fingers in and do one of those. Like, right, you want to get your mom, so you get your hand wet and you do that to her. We're going to do that to a couple of those pieces of bread just to get a little bit of water on it, right? We're not going to want to dunk the bread, but we want a little spray of water when we set this up. All right, I want to let you go. I know this has been a long video. It's almost 20 minutes. Um, I look forward to the next one, right? Next one's going to be the setup of the mold experiment. I want to thank you guys for joining me, and I look forward to seeing you next time. Say bye, Jeff.